Welcome, pilots, and get ready to strap in. I am your flight director, and today we are initiating a full-scale mission control flight simulation. Now, our primary objective on the central console for this explainer is a notoriously tricky system to navigate. We're talking about Cambridge AS and A-level accounting, and specifically the break-even point calculation from syllabus 9706. To help us monitor our approach trajectory today, we actually have some telemetry pulled from two previous pilots. Let's call them Pilot Alex and Pilot Sam. Look, Pilot Alex is the kind of student who tends to completely overcomplicate data calculations. They end up burning way too much cognitive fuel right out of the gate. And then there's Pilot Sam. Sam's a bit of a maverick, but not in a good way. Sam often ignores the strict structural boundary constraints of the questions, which honestly risks a complete systemic breakdown during re-entry. So my job today is pretty simple. I'm going to guide you right past their mistakes. We are going to treat this exam paper exactly like a delicate, highly complex flight system, and together we're going to execute a flawless touchdown. Ready? Let's get into it. Okay, so here is the flight plan for today's mission. First up, we have our pre-flight core principles. Then we'll move into executing technical trajectories. After that, we'll be navigating examiner debris, and finally, we'll initiate our mission success and evaluation protocol. We're going to systematically clear each of these stages to make sure you get that perfect landing. Okay, let's dive into this. Section 1, Pre-Flight Core Principles. You absolutely cannot pilot a spacecraft if you don't actually understand the fundamental physics of its engine. And in that same exact way, you simply can't ace this accounting paper without fully understanding the core assessment objectives. The Cambridge examiners aren't just glancing at your paper. They are actively targeting three very distinct cognitive domains. They are scanning your answers for knowledge and understanding, they want to see analysis, and they are looking for evaluation. Now, this right here is exactly where we see Pilot Alex burn up all that fuel. Alex is famous for providing this massive, overwhelming breadth of basic knowledge, like literally listing every single formula they have ever memorized. But here's the thing. The Cambridge system heavily prioritizes analytical depth over just superficial breadth. You really need to push way past simply defining what the break-even point is. You have to analyze what it actually means for the business's operational trajectory moving forward. That's the secret sauce. Now, I want you to pay close attention to this, because the principal examiner reports issue a very clear, direct command on this topic. They say, and I quote, "Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts." So what does that actually mean for us? It means cross-topic connections. The examiners want to see that you get the big picture. Let's say your break-even scenario throws a curveball at you, a sudden unexpected change in variable costs. Well, how does that ripple through the rest of the system? How does it impact the margin of safety? What does it do to their pricing strategies? Referencing these specific causal relationships between different parts of the syllabus, well, that is the exact thrust that propels you to those significantly higher mark bands. You have to show the examiners that you see the entire interconnected flight system, not just a single flashing button on the dashboard. Moving right along, Section 2, Executing Technical Trajectories. Okay, so let's talk methodology. Mastering these multi-stage calculations absolutely requires you to treat them as a strict sequence of system parameters. You can't just wing it. Walk with me through this exact 5-step standardized sequence pulled straight from the syllabus. Step 1, identify key elements. That means accurately extracting your fixed and variable costs from the data they give you. Step 2, apply relevant principles. This is where you select the precise formula you need. Step 3, execute your analysis. And crucially, do it with clear working. We'll talk more about that in a second. Step 4, verify your results. Do a quick sanity check for reasonableness. Does this number even make sense? And finally, Step 5, present your findings in the appropriate format. Using this visual story method, treating it like a mandatory pre-flight checklist, completely prevents the kind of systemic breakdowns we see when pilots just try to guess their way through the data fog. And that specific step about showing your working brings us to something absolutely critical, the method mark strategy. Listen, in Cambridge accounting, marks are awarded for the process, not just the final destination. The examiners are literally looking for your telemetry. If you meticulously show your step-by-step working out, you actually secure those method marks even if your final calculation goes slightly off course because of some minor arithmetic error. Pilot Alex? Yeah, Alex almost always skips writing down the intermediate steps to save time. And guess what happens? When that final answer is wrong, it is a total system failure. 0 marks, none. So show your telemetry every single time. Now listen up.
Before we fire the secondary boosters and dive straight into the danger zone to secure those maximum marks, you need to optimize your own flight path. Take a second, subscribe to Ace the Exams at the handle @AceTheExams right now, and turn on all your notifications so you never miss a simulation. Okay, boosters engaged. Let's keep flying.
All right, buckle up. Section 3, Navigating Examiner Debris.
Warning pilots, we are officially entering a high-risk zone. It is time to activate debris detection. We need to avoid the most common systemic breakdowns that are repeatedly flagged in the examiner reports. I'm going to rapid-fire the top 3 warnings right now. First, vague details lacking specifics. Second, forgetting to check your format and presentation boundaries. And third, providing generic answers that are not specific to the given context. Look, this right here is where pilot Sam always takes a massive hit. Sam has a habit of ignoring the structural boundaries of the question entirely and just spits out a memorized textbook answer. If you ignore the specific context of the business they've handed you in the paper, your trajectory will fail. It's that simple. To prove it, I am initiating an interactive viewer radar challenge right now. I'm putting a 60-second visual countdown clock on your internal radar. I want you to really look at the screen. Compare the generic answer on the left to the context-specific answer on the right. Scan them. Use your radar to spot exactly why that generic answer is a complete system failure. Do you see it? It completely fails to mention the specific business name. It doesn't reference their actual product. It completely ignores your unique cost constraints. It's just a blank template. So, to save our trajectory here, I am overriding the console. I am injecting the Peel structural template right into your system. Point, evidence, explain, link. Every single point you make must be linked with hard evidence back to the specific given scenario. This is exactly how you dodge the examiner debris and stay on course.
We're almost there. Section 4, Mission Success and Evaluation.
All right, we have successfully cleared the debris field, and we are now approaching the final touchdown sequence. Remember earlier when we talked about those cognitive domains? Well, to hit the absolute highest descriptive, analytical, and evaluative levels, you absolutely must use this higher order framework. Deconstruct, solve, evaluate. First, you deconstruct by identifying the given information and breaking it into logical steps. Then you solve it systematically. After that, you check your reasonableness. And then, and this is literally the most critical part for those top-tier marks, you have to make justified recommendations based on your break-even findings. Should the business lower their price? Should they switch suppliers to reduce variable costs? Whatever you decide, you have to solidly justify your flight path to the examiner. And this brilliantly illustrates what separates the elite pilots from everyone else. Evaluation of evidence quality requires identifying limitations, the assumptions made, and alternative interpretations. Let's be real. Break-even analysis assumes that all output produced is actually sold, and it assumes that fixed costs remain perfectly constant. But in reality, come on, what if the business suddenly has to pay overtime? What if market demand drops unexpectedly? Top students, the ones who get the flawless scores, they look way beyond the raw numbers. They evaluate the effect of these assumptions and these real-world alternatives on their final conclusions. That's how you show true mastery. And just like that, Alex and Sam confirm a successful full-mark touchdown sequence. We made it. To distill everything from this session, remember to always use your pre-flight question scan checklist. Identify, apply, execute, verify, present. And always use that Peel structure for your context. Before you log off, I need you to drop a comment below sharing your subject and tier so we can prep for our next simulation. And of course, ensure you are subscribed to Ace the Exams at Ace the Exams with a notification bell on. Mission accomplished, pilots. I will see you on the next flight. But before you go, I want you to run your own pre-flight scan on this final provocative thought. When facing your next break-even scenario, what alternative interpretations and justified recommendations will you use to secure your context marks?